Hello friends, welcome back to our channel. Today, in part 4.8 of Mastering Parallel Programming in C series, we are diving deep into efficient task creation with TaskFactory. Whether you are new to parallel programming or looking to enhance your skills, this video is packed with valuable insights. So, before we get started, just a quick reminder to subscribe my channel, hit the red button, and don't forget to click on the little bell icon. That way, you'll be notified every time I upload a new video. Okay, without any further delay, let's get started. Parallel programming using PFX, that is Parallel Framework Extension Libraries in C Sharp. If you have watched my previous videos, you probably remember this diagram. Well, today we'll go ahead one more step further and learn efficient task creation with TaskFactory. Efficient task creation with TaskFactory. First, let's talk about Task.Factory. This is a static property of the task class. When you call Task.Factory, it returns a default instance of the TaskFactory class. This default factory provides a convenient way to create tasks without needing to instantiate a task factory object manually. Okay, let's understand it with the help of examples shown over here. So here, I'm using default task factory to create a task. That's what I have written. Task is equal to task.factory dot start new, and here I'm passing this action delegate in terms of lambda expression, where I have written console.writeLine channel learn enjoy is awesome. So basically in this example, we are using the default task factory to create a task. That's what I have written task.factory. Then we are calling a start new method to start the task. Here what I am doing, I am just passing in an action delegate in terms of lambda expression. That's how we are going to create a task with the help of default task factory. That's why we are using task.factory, a static property over here. Now let's move on to task factory as a class. Unlike the default task factory, we can instantiate this class to create custom task factories. This allows us to set specific options for task creation, task continuation, or even task scheduling. So here, let's understand it with the help of examples shown over here. Let's suppose if we want to create tasks that are long running and attached to a parent task, we can set up a custom factory like this. That's what I have written, where custom factory is equal to new task factory, task creation option dot long running, and task creation option dot attach to parent, comma task continuation option dot none. So this is how we are going to create a custom task factory with a specific option shown over here, right? And then what we need to do, we need to use this custom factory to create a task. That's what I have written. Task custom task 1 is equal to custom factory dot start new, and here again I have written action delegate in terms of lambda expression. What I have written, opening closing parenthesis goes to console.writeLine custom task 1. Similarly, I am creating a custom task 2. That's why I have written again task custom task 2 is equal to custom factory dot start new. Here also I pass this action delegate in terms of lambda expression. So overall, in this example, what we are doing, we are creating a custom task factory with a specific option. So this setup is useful when we need to create tasks with non-standard settings repeatedly. So in this example, we configured the custom factory to create long-running tasks that are attached to a parent task. That's why I have written task creation option dot long running and task creation option dot attached to parent over. So what exactly is task factory? So it's nothing but a class that helps you to create tasks which are unit of work that run asynchronously in the background. Then we need to understand what is the role of the task factory. So here, the role of the task factory is to generate three types of data. Number one, common task. How we are going to create a common task with the help of start new method. Then we can go for the continuation with multiple antecedents via continue when all and continue when any. Then third type of task we are going to create with the help of task factory, a task that wrap methods that follow the asynchronous programming model via from async. Okay, so let's switch to the Visual Studio and see all these things in action. Okay, so now we switch to the Visual Studio. Here we are going to see the demo of various ways of creating and managing tasks using the Task Factory class in C Sharp. To show the demo, what I have done, we have created one console application named Task Factory demo that has program.cs file. In program.cs file, first of all, I included namespaces. Then there is a class named program that has main method, which is an entry point of this application. So in this method, what I have done, I wrote different task creation and handling methods. Firstly, I have created task using default task factory is using task.factory static property and calling a start new method where I passed an action delegate in terms of lambda expression. What I have written task is equal to task.factory. This is nothing but the static property, and here I am just calling this start new method. Inside that, I have passed this action delegate in terms of lambda expression, and what I am doing inside that, I am just printing this statement into console. channel Learn Njoy is awesome. Then I wrote task.wait. This statement basically is going to wait for the task to complete before proceed. Post that, what I'm going to do, I'm going to show the demo of task creation using TaskFactory class. That's what I have written this statement, task creation using TaskFactory, that is going to get printed into the console window. So here what I'm doing, I'm just creating a custom TaskFactory with a specific option. That's what I have written, where custom factory is equal to new TaskFactory, and here I'm just mentioning the task creation option. What option that I'm mentioning over here? Mentioning task creation option dot long running and task creation option dot attached to parent comma task continuation option dot none. Here I'm just going to use this custom factory to create a task. What I have written, task custom task one is equal to custom factory dot start new. Beside that, I'm just passing this action delegate in terms of lambda expression, and here I'm just printing custom task one into the console window with the help of console.writeLine state. Similarly, I have created custom task 2 using this custom factory. That's what I have written, task custom task 2 is equal to custom factory dot start new. Here also I have passed this action delegate in terms of lambda expression. Here I'm just printing custom task 2 into console window with the help of console.writeLine state. Then finally I have written this statement, task.wait all custom task 1 comma custom task 2. So this statement basically is going to help us to wait for both the tasks to complete before proceed. Finally, I am going to show you the role of TaskFactory class, that is for creating the different variety of the task. What are those variety? Number 1, common task using start new. Number 2, continuation with multiple predecessors. Number 3, tasks that encapsulate method following the asynchronous programming model using from async. Okay, let's see them one by one. So number 1, common task using start new. Here I'm just creating a common task with the help of taskfactory.start new method. Inside this, what I'm doing, I'm just printing this statement into console window, common task started. Then I have written this statement, task.delay 1000.wait. So this statement basically going to delay for 1 second, and here with this statement I'm just simulating some work done over here, right? So that's what I have written this statement. And finally I'm just printing this statement into console window, common task complete. Then I have written this common task.wait. So this statement is going to wait until common task gets complete. Now let's see the second type of task, continuation with multiple predecessors. So here we are creating two tasks, task 1 and task 2 using taskfactory.start new. What I have written, task 1 is equal to taskfactory.start new. Here inside I have printed task 1 is started into console window with the help of console.writeLine state. Again here I am just simulating some work, and finally I am just printing the state task 1 completed. Similarly, I have created task number 2 with the help of taskfactory.start new. Here also I am just printing this statement, task 2 is started with the help of console.writeLine statement. Here I am just making this task to delay for 2 seconds. What I have written, task.delay 2000.wait. Finally, I'm just printing this statement into console window, task 2 complete. Then I wrote taskfactory.continue when all, task 1, task 2. Inside that, I'm just printing this statement, continuation task continue when all started after task 1 and task 2 complete. Next, I wrote taskfactory.continue when any. Here I'm just passing these two task reference, task 1 comma task 2. With the help of this continuation task any, this statement is going to get printed. What statement I'm printing? Continuation task continue when any started after one of task 1 or task 2 complete. So here basically we are showing continuation with multiple predecessors. Next we have number 3, tasks that encapsulate method following the asynchronous programming model using from async. So here I wrote the code to perform an asynchronous web request, processes the response. It also includes a continuation task to handle the result or exception of the asynchronous task. So here if you see, I have written task string from async task is equal to taskfactory.from async. So this statement is going to create an asynchronous task. Inside that I have written callback comma state goes to, and this statement, web request is equal to web request.create https google.com, and finally I'm just returning. And here if you notice, I have used this begin get response. So begin get response basically initiate the asynchronous operation. Finally if you see, I have written end get response over. So here it completes the asynchronous operation and reads the response. That's how we are going to read and return it. And then I have written the continuation to handle the result or action. Here what I'm doing, I'm just going to continue with task status is equal to task.run to completion. If task gets completed successfully, then this statement is going to get printed into console. promising task completed successfully. What is the response line that I'm going to print into the console? If task did not get completed successfully, if it is having failure, then this statement is going to get printed into console window. Promising task failed. What are the exception we are going to get it? That is going to get concatenated with this statement and it is going to get printed into console window. Finally, I'm waiting for the promising task to complete before exiting the program. Okay, so that's how the program is structured. Let me execute this program and witness the output. Okay, so output got appear into this console window. If you see, first of all, this efficient task creation using TaskFactory demo got printed. Here I'm just using this Task.Factory static property to create a default task factory. What I have written, task creation using default task factory, that is using Task.Factory static property. I have printed this statement into console window, right? That's what this statement got printed. Channel Learn Enjoy is awesome. Then I'm going to use TaskFactory class for creating a task. That's what I have written. Task creation using TaskFactory class got printed. Here, custom task 1, custom task 2. So common task started, common task completed got printed. Task 1 started, task 2 started, task 1 completed. If you see, this statement got printed. Continuation task continue when any started after one of the task or task 2 completed. Then if you see, task 2 also got completed. So that's why this statement got printed. Task 2 completed and then continue when all method got invoked and this statement got printed. Continue task continue when all started after task 1 and task 2. And then from async task completed successfully and response length 59270 got printed. These two statements got printed where I have explained you how we are going to create a task that encapsulates method following the asynchronous programming model using from async. Okay, so that brings me to end up my session today. Sum up, understanding TaskFactory and how to utilize its features can significantly enhance your ability to manage and create tasks in C#. What I suggest you, just go and experiment with both the default and custom TaskFactory. Find out what best suits your needs. That's all for this video, guys. If you like this video, hit the like button, share it with your friends and colleagues, subscribe to my channel if you haven't done already. Thanks for watching. See you next video.